Salutare, mă numesc Titian Cernicova-Dragomir. Actually, I'm going to continue this in English. I'm more comfortable speaking in English for this presentation, at least. I'm a software engineer in the JavaScript TypeScript infrastructure team at Bloomberg. I'm also a TypeScript compiler contributor. And today we're going to talk a little bit about advanced types, and we're going to start with sort of, should you actually try to use more advanced types in your code, and what exactly is an advanced type? And we're going to go a little bit into some code, talk a little bit about discriminated unions and a bit about mapped types, and then we're going to sort of have a little roundup and final thoughts. So, should you use advanced TypeScript types at all? Lots of people have lots of opinions. It's very easy to start a flame war online these days. It's very easy to have a very clear opinion when you're writing in a very, very short amount of text. I don't usually agree with that. Don't trust every influencer you hear out there. Simple views are usually not accurate. Things are always more complex and more nuanced. The classic answer, it depends. Well, usually it does depend, and I know that's not a particularly satisfying answer or one that's necessarily favored online, but it is the accurate answer a lot of the time. So, should I use complicated types? So I'm just curious, how many of you think that they have used TypeScript, complicated types in TypeScript? Show of hands. 1, 2, 3, 4. Okay. So, I think that it really depends on what we mean by complicated types. When it started out, everything is complicated, ultimately. Programming doesn't come naturally to any of us. It's not a skill we're born with. Make sure you have enough experience with the type system before you dismiss something as too complicated, and try to get comfortable with what is there and the power that is there before you say, oh, I don't want to go that far. So I would have some thoughts and some advice, if you are starting to delve into more advanced things. For example, the first piece of advice is, make sure the pattern you are using is well documented. And there are plenty of well-documented patterns out there that could be useful, and they seem more advanced at first, but they're not that advanced if you're used to them, and they're pretty simple to understand. For example, we're going to talk about discriminated unions, and again, show of hands, how many of you have used a discriminated union? Oh, and that's a fair number. Interestingly, I see that it's not the same people who said that they do advanced TypeScript types, which is interesting, because for some people, for the people who didn't raise their hands, discriminated union might seem a little bit weird and advanced at first. So, I think unions are pretty much a staple in TypeScript programming. You can't really do programming in TypeScript without some sort of union, right? We use unions even to represent things like nullability and the ability to have to allow undefined in a value. So unions, I'm assuming that everybody has used. So what makes a union discriminated? Well, what makes it discriminated is that it has a field that allows us to select one of the constituents of the union, and that field is usually of a literal type. Not always, but usually, and we're going to see one of the exceptions. So let's take a look and see exactly what exactly are we trying to achieve with something like a discriminated union. So let's say we have a very basic React component here. I'm not going to delve too much into its implementation. It doesn't really have one actually, but it has some props that it's taking in, right? And this particular component can either represent a list that allows you to single select or multi-select. Okay, what is the problem with this, with the props of this particular component? Well, the problem is that we have sort of in the single type mixed options for both single and multiple selections, right? We can see that the onSelect can be either a callback that will receive string or undefined, right, for the single selection case, or it will receive an array of strings for the multiple selection case. We can also see that the value can be string or undefined for the single selection case, but also an array of strings for the multi-selection case. And this sort of creates problem both in the implementation we can see here that we have a lot of red squigglies. Some of these red squigglies are good. So for example, if we check that we're talking about the single selection, probably we don't want to be able to call onSelect with an array. But some of them are obviously wrong, right? Again, if we had onSelect and we checked that type is single selection, well, we'd probably want to be able to pass a string in there. And TypeScript sort of synthesizes from that union we saw above, from the union of the callbacks. It synthesizes this weird thing where it expects value to be a string and an array of strings, which is not something that you'll ever see in nature, right? This is a weirdness of what of the type system. It's a natural conclusion of the type system, but it's not one that is particularly useful to us. And on the usage side, things look, we don't have any red squigglies, but probably we want some, right? I mean, here we said that the type is single selection, but we're passing in an array of strings and probably the selection with an array of strings, right? So not the best developer experience. So how can we fix this? Well, the simple answer is we can transform this into a discriminated union. And we have here a field that obviously lends itself to this, and that's very important. Not every data structure you have has this field. You might want to add it in some cases more synthetically, but here it's pretty obvious what that field is, and that is the type of the selection, right? It's either single selection or multiple selection. And we're just going to copy that for a start. And now we're going to just keep the options that are relevant for each case. So for example, for the single selection, well, we don't need this callback here. And we don't need, value can only be string or undefined. It cannot be an array. For the multiple case, well, we do the exact opposite. We are going to keep the other callback type here. And we're going to delete the string or undefined because the value is always going to be an array of strings. Okay, so what happens now? Well, when we check type, right, something magical happens in the type system here, because here if we hover over onSelected, we can see now that the callback is now, the version of the callback that's suitable for the single selection. And if we go on this side, we can see that it's the other one is the one that's suitable for the multi-selection case. This also applies to the value, and we can see here that we actually missed a null check, so maybe we could do that. And on this other side, we can see that value has been narrowed to being just a string array, right? So what TypeScript does is kind of sort of magic here, because it looks at the fact that all of these variables came from destructuring something that is a discriminated union. And it says, well, if I check type, then that means I have more information about onSelect and value, right? Their type is not the same. It has been narrowed to whatever was in the original discriminated union, right? And this is sort of a very easy way you can sort of keep the patterns that you're using, but get TypeScript to understand more of it. Right? We could also have used a single object there and just access each one of those properties individually, and TypeScript would understand that as well. But I think sort of showing the destructuring case is sort of a little bit more interesting, because it's something that perhaps it's not obvious that it actually works if you don't know it does. Discriminated unions, both object and tuples can be discriminated unions. I'm not sure how many of you, show of hands, who is familiar with tuple types? What's a tuple type? That's a decent amount. So a tuple type at runtime is an array, but in TypeScript, when we define a tuple type, it means that we're defining the structure of the array, right? We say that, for example, in this case, we've defined a tuple type that has two elements. We can see that there's a comma in the middle there. The first element of the array is going to be undefined or error, and the second element of the array is going to be some API response or error, right? And what I'm trying to do, what this function is trying to do here is, if I'm making an API request and it might error, if it errors, I'm going to get back the error as the first element of the tuple, and if I don't get, and if the request succeeds, I'm going to get the response as the second element of the tuple, and the first one is going to be undefined because I don't have an error, right? Why would you want to use this pattern? Well, some languages, for example, use this pattern by default because it encourages you to actually check more explicitly for errors, right? So it's a pattern that you can't just assume that you get the data. You actually have to handle the other case more explicitly. So that has its own benefits, right? And so yeah, there are reasons you would want to use this particular pattern. But the problem with it is when we actually try to go here and use this function, right? We destructured our data, we have our error in here and our data, and we checked if error is undefined, right? If error is undefined, that means the request was successful, so that means data should contain something. But TypeScript is being, is being annoying and it's telling us, well, data could possibly be undefined. But I know it can't be undefined, right? I checked the error. Data shouldn't be undefined. So what we can do is we can sort of take this tuple type and create a union, right? And again, similarly to what we did before, I'm just going to copy it, and we're going to try to sort of split these two cases apart, right? Right now they're sort of entangled, and we're going to try to split them apart. So if we get an error, well, that means the second element cannot be an error. It has to be undefined. If we get undefined as the first element, that means that definitely we're going to have an API response as the second element in that tuple. So what happens now? Well, TypeScript, again, now that we have given it this information, it can now understand more clearly what it is we're doing, right? Because this pattern here also has this undefined, which can be excluded. Right? It's one of those literal types. Well, after we've checked that our error is undefined, well, data now is also narrowed to be just the response, and it doesn't contain undefined in the type anymore. Now, maybe a question I should answer is, why are we using a tuple and why not to just use an object? Would this be better if I just use an object? Why am I returning an array? Anybody want to venture a guess? Why is it better to return the tuple and not return an object with error and data?
Another field. You're going to have an object with a discriminating field like in the first example.
Well, so personally, I think that this pattern with tuples is important because object destructuring is just much more cumbersome in JavaScript, right? If you want to also rename while you're doing it, you have to provide the old name and the name you're destructuring to, right? Much like with use state in React, right? If I want another one, I can just rename these, and I don't care what the name of those properties was in the initial object, right? If I would have used object destructuring, I would have had to go here, error colon error 2 and data colon error 2, right? And right, assuming this thing returns something with error and data, right? Which is just a lot more to write, and I don't really care what the original names were in that object. But yeah, so this is a pattern that you can use, and TypeScript will understand sort of the fact that if you have a tuple, this can also be discriminated by one of its members. Was this complicated? I don't know. I've been exposed to this enough that I don't feel that it is complicated. Somebody coming into TypeScript might think that this is weird and this is not something that they know, and that's fine. We've all been there. We're all learning all the time, but this is a well-documented pattern, right? If you go online and you look for discriminated union, you can read about a discriminated union, and if somebody comes to you and say, what is this weird thing you're doing, you can point them and say, just go search for that, and it is something that they will be able to understand. The other sort of thing I would like to say when you're thinking about using something more complex, make sure that it's worth the extra complexity. If you're going to write a function that you're going to invoke once, there's no point in going overboard with weird generics and doing all sorts of complicated things. That's overkill. You're wasting your time at that point. But if you are deciding, for example, a function that it's a mini library within your application and you plan for everybody to use it in 1,000 pages, well, that's the moment when investing more in better types starts to pay dividend, right? It starts to matter and it starts to sort of pay for itself in the developer experience of the people who are using your library. So one thing to point out is that when you are doing this, is what you want to do is usually you want to improve the call site of your library, and that's where you want to focus on the X, on the developer experience, not in your own function. And we're going to see that sometimes these two actually clash, and you're improving the experience for the developers who are going to be using your library, but you're making your own experience as the writer of the library worse. So let's have a look at what I mean by this. So a lot of stuff in TypeScript, if you want to do more advanced things, has to start with some sort of generics. There's no way around that, right? And functions are the typical vehicle that allows us to capture information and to start really going to this world of more advanced types. So, just a short primer about what generic types are and how we can use them, right? So we can declare a generic type with those angled brackets right near the name of the function. That's a generic parameter. It has more complicated options, but we don't care about those now, right? And once I've declared it, I can use it anywhere within the signature of the function and the body of the function, right? It's just another type. Right, so I can declare here that I have a parameter p and it's of type t. Okay, and if I actually use this function now, and I pass it there, for example, 10, TypeScript will say, oh, you're passing in a number, so that t is going to be number. That's what TypeScript infers, right? It tries to deduce the type that you meant there. Now, if you're using a type parameter only once, not considering the declaration, you're doing it wrong, right? There's no point in having a type parameter that is used once. Type parameters are used to tie together either parameters to other parameters or return types or the parameters to the return type, right? So for example, if I have another parameter, right, and I say that, okay, my function, the first parameter is some value of type t or undefined, and the second parameter is a default type, and that has to be of type t. Right? I don't care what that t is. I just care that both of these, in both locations, that t is the same type. So that's the relationship I've established. So now if I were to invoke my function, for example, with a number or undefined, right, and I do this particular call, well, t is going to be number. So the actual type for the first parameter is going to be number or undefined, and the second parameter type is going to be just number. And that's what TypeScript is going to enforce. If I try to pass in a string as the second parameter, TypeScript is going to say, well, this doesn't make any sense. The first parameter you passed in sort of led me to believe that t is supposed to be a number, and now your second parameter is giving me the impression it's a string. Something's not right there. Right, and there is an argument. You could infer a union, for example, and you could say it's number or string, and that would satisfy both parameters. But that wouldn't really be useful. And I think Ryan Kavanagh, one of the members of the TypeScript team, has a very interesting talk about what decisions and what guided the decision in sort of deciding when sort of to merge things and to create unions, and when to say no, these don't match, and there's a problem there. So if you want the talk online, I definitely encourage you to listen to it if you're interested in these things. So what can we do with this power, right? Or I forgot to mention. We can also tie it to return types. We can put the return type there, and then what that means is that the return type for this function is going to be number. So let's see how we could use this, right? And a hook I've sometimes created and used when I did more React development was this particular hook, right? Use modal hook. And what it does is it gets a component, and that component needs to have an on-close as its props. And it also returns what it returns is basically a function which returns a new promise. And what happens is that when this new promise is going to resolve, when this component is going to invoke its on-close, and whatever value the component passed is going to be the return type of that promise. And here we have an implementation of this as an example, right? We have a question component. It's going to give us back yes or no, and it invokes that yes or no depending on which button you press. And now, when I try to use this, you say use modal of question, and now I say open the modal, and then if the result is okay, do something. Now the problem is that the component itself is going to give me back yes or no while I'm checking for okay. So that's not right. The reason for that is that I'm basically getting here a promise of unknown, right? And I'm just gonna do a quick change here, which I forgot to do. Right? Let's say any. That's a little bit closer to what I wanted. So so the problem is that open, returns a promise of any. But the actual root cause is the fact that use modal, right, doesn't take the information it gets when we call it, and because here we see that this component is going to return yes or no. It's not taking this information in, and it's not forwarding it to this open to the open function it returns. And the way to do that is to use some generic type parameters. And like I showed in the example, we can just declare one here. And now we can use it anywhere where we previously used any because we didn't have a better type, right? So we can use it here in the signature. And now if we go and we hover over the use modal, we can see that T has been inferred as yes or no, right? TypeScript won't print out the type parameter name. It'll print out what it thinks that T should be, right? What the type parameter should be. But the promise is still of any, right? Because we didn't actually use that type parameter in other places. So let's try to do that. So here, the resolver for the function is going to also be of type T there. And most importantly here, the promise is we're going to pass it the generic parameter T there. And now what happens is that we basically take the information from the argument we passed in, and we forward it to the open function that we return. And now when we call this open function, the result is going to be of type yes or no. And TypeScript can now give us better errors, and it can forward this information. Now, this isn't a particularly complicated use of generics, but again, if you're just using it once, is it worth it? Probably not. But this component has a very generic sounding name, right? If you're going to create a hook, you probably intend to use it in more than one place, hopefully. So it does make sense to spend a little time and fine-tune the developer experience of people who are going to end up using this hook. So one more piece of advice I have when you're trying to do something more complicated in the TypeScript type system is that make sure that there are other people who can understand what you're doing, because it's very easy to combine all sorts of weird types in TypeScript, conditional types with map types. They're often hard to understand. Even for the person that wrote them, this is some code I wrote at some moment in time, and it does what it's supposed to. It's pretty interesting code. I was very happy when I wrote it, but then 6 months down the line when I had to look at it, I was like, I don't remember exactly how any of this works. And I'm sure that other people around me probably also didn't understand. It starts to look a little bit like Elvish. You look at it and you're wondering, what is this Elvish script? And you have to go and try to decode it. And the problem is that it's hard to debug. There's no debugger for types. The only thing you could do is hover. You go with the hover in Visual Studio Code and say, oh, that's the type. And then you try to split something out, and then you hover again. And the problem is that if you split something out, it doesn't always behave as it does in the place that you wrote it. So you need to be mindful of that. And it's not great, not a great experience. So make sure that if you're doing that, it's really, really worth it, right? I'd also tell you to prefer built-in mapped and conditional types. TypeScript already has things, for example, to change modifiers, like partial, read-only, and required. Right? The implementation of these are with mapped types, and we're going to see what a mapped types look. But if these satisfy your use case, just use these. We can manipulate properties with some of these types. You can, extract types as well from other things like parameters, return type, and instance type. All of these are really useful, and you can use them because they're already in the base library. You could perhaps also use other libraries that offer types. I would caution you a little bit to research the library because some of these also go overboard with some of the types. So, careful. Make sure that the developer experience you're going to get is something that you actually want, because a lot of the time the errors that you'll see will be so impossible to understand that it's worse than just letting the runtime error. But just for fun, let's see what one of these map types looks like, right? So map types you can think of sort of basically like an iteration. It's a for loop, but in the type system. It's often paired with key of, right? We're iterating over the keys of a particular type. For example, in this particular type map type in M, I'm iterating over the keys of another object type O, right? And O has first name is student and age, very simple type, and sort of the iteration variable is this P type here. And we can specify what the type of each property is going to be. That's basically the whole point of a mapped type. We map the properties, we keep the names usually, but we map it to another type. And we also usually need to index back into the original type, right? So if P is the iteration variable, right, we can use P to go and look up other types in the original type. So for example, if we were to sort of spell out what this map type does, right, P is going to be first name for a start, right, and then it's going to say, oh, you had O of P, that's O of first name. The type of that is going to be string, so that's the result, that's the type in the result. Is student, right, we're going to index with that into O. We're going to get Boolean, and that's the final type. And for age, similarly, we get number, and that's the final type of the age property. Now, this is just basically an identity type. It's not particularly useful. The interesting bit comes when you actually start to do some changes there. And we're going to have a look exactly what a possible use case for that would be. So let's say we are building some sort of validation for, we want to build our own use form hook. Not saying that's a great idea, but let's say we do. Let's say we've used all the open source versions and we've arrived at the conclusion we can do better. And our hook takes three things. It takes the current value of the data form, right? It also takes some sort of setter to change that when the value needs to change. And it also takes in an object that contains sort of validators and converters for each one of the properties in the type. So I think it's easier to understand with sort of an example, right? We have use form, we pass in the current user, we pass in the function to set the user, and then we have some sort of validation logic and transformation, right? For example, for age, we want to validate the range. For first name and username, we don't want any validation. We're just returning the same string, right? And there are some problems in here, right? I'm returning the same. I'm returning the string, but I'm converting it to number here for some reason. That's obviously a mistake, right? If I probably want to preserve the same thing. And actually, for age, I'm not even returning anything. I'm doing the validation, but I'm returning undefined. So, if you're going to write this hook, and it's going to be used a lot in your application, it is worth spending some time making sure that when people use it, they don't shoot themselves in the foot, right? It's worth it to make sure that it catches at least the trivial mistakes, and if anything else happens, you can have actual tests for that. But let's see how we can improve the type for this. And then the first thing we're going to need is a type parameter for this function. Right, so we're going to add this type parameter t here. We're getting some data t, and we also want the setter to accept the same thing. That wasn't enforced before. And that's a good start. At least people need to make sure that these two are tied together. And now here for the validators, the type here is record of string and a function that gets a string and returns an any. As a first approximation, we can keep record, right? And we can say, well, record of string if the first parameter is string, that means it can have any property, right? It's basically the same as it being a dictionary. I don't want it to have any property. I want it to have the same properties as my original type T. So I don't want there to be string. I want to say here it's key of T, right? It's a record that contains the same keys as the original type, and they're all mapped to a function. And this already is an improvement, right? We see here that somebody misspelled username, and we can fix that now. We even get IntelliSense, which is nice. Right, and yay, we've already made an improvement with minimal effort. Now, here as the return type, we say that the return type is any. Can we do better? Well, with record, we can do a bit better, but not get all the way there, right? Ideally, we would want to say that the function we get for age returns a number, and the function for first name and username are going to return strings. So we can't get all the way there with record, but we can get closer. We can say here that the return type is T indexed by whatever keys T has. And this might look a little weird at first, right? And if we were to try it out for a concrete type and say here type, I don't know, X equals user key of user, we can see that the type we get is a union between string or a string and number. Why is that? Because the properties in here, right, have only the type string, number, and again string, right? If we were to add something else in here, such as Boolean, then this would also be, that new type would be added, right? So it's not perfect, but at least you can't, for example, return undefined from here, right? Because that's it's in none of the properties in here, right? So it's not the type of any of the values. So we have to do something here to fix this value, and so let's say we just discover that were not returning the value. Again, this gets us a lot of benefit. Again, just using built-in types, right? You don't have to don't have to write anything custom. There's not a whole lot of weird dark magic involved. It's just types that you find in the base library. Now, there's still this particular error here, which is a bit nagging, right? Because you're returning some other type instead of string for first name. Now, for that, unfortunately, we can't use record anymore. We need to go into actually writing our own custom mapped type, right? And how are we going to do that? Well, let's see, first of all, what a version, the spelled out version of record would look like, right? So we can say here that if we want the exact same type as what we had before, we say P in key of T, right? And all the properties have this particular type, right? They're all this function that returns anything that's any type that is within the original type we had, right? And this is basically equivalent to the record we had, right? It's not catching any more errors, right? But now we don't have to index here with all of the keys of the original type T. We can say we want to index with the property we're iterating over at that time, right? So we can say here that we're returning T of P, right? So just as here before we saw that, T O of P, resolved to the type of the particular property inside the original type. Similarly here, T of P is going to resolve to the same thing, right? To the original type of the property. So now when we hover over these, we can see that age should be something that returns number. First name should be something that returns string, and we also already get an error here. And username again should be something that returns string, right? And this is pretty type safe, and the developer experience is going to be good. Errors are going to be easy enough to read. Now, I did mention at some moment a while ago that sometimes improving your developer experience for users is actually going to make your job as the person developing this harder. And people often get stuck on this, and they say, well, if I can make my clients type safe, then I gotta make my own stuff type safe, right? I'm telling you, don't worry about that. With generics, the point is to optimize for the call site. not for your implementation. Your implementation inevitably is going to have some unsafe things in there, simply because TypeScript cannot follow everything that happens with the generic types. It just gives up at some moment in time, and it's going to give up sooner or later. So for example, here it says that, t is not assignable to parameter of type, whatever. I mean, there are ways to fix this. For example, I think that this particular one is because t could be any type, but key is expected to be an object. So we can say here extends object, and we got rid of that one. So that's something that is simple to do. But other things are not that simple to fix, right? So for example, here we say that it says that element implicitly has an any type because the expression string cannot be used to index the type empty brackets, which is always a nice error, right? So basically we're trying to index into this t type, and TypeScript goes, well, I got no idea what's in there. Is that safe? I don't know. Maybe. It's on you. Right? So you could spend like 5 hours and try to find a type safe way to access this, or you can just go as any. And that's fine. You have my permission to do it. I hate any, but this is a good use of any. Right? I don't mind this, right? Because this function I can look at, right? And I can validate that it does what I want. I can write tests for this function and validate that it does what I want. The types are for people who are using me, not for this, right? And again, here, same problem. I'm indexing into this function with this key, and then I'm trying to call it with some string value, and I'm trying to assign that, and TypeScript just gives up and says, well, I don't even know what you're trying to do here, man. It's weird, like, and it will spit out these, no index signature with parameter of type string was found on the map type I just wrote. Well, yeah, that's the point. It's not supposed to be there, right? So again, you could use any here. Or another trick that I've sometimes done is you have two signatures. You have one signature for people who are using you, and a different signature for your implementation. Right, and in your implementation signature, you can say, oh, this is any, and this is any, and I just want to do whatever. And maybe I don't want to go straight to any here, but maybe at least just this. This is fine, right? So there are things, and the beauty of this is that this only has. I need to put a return type now here, which I don't recall what it was supposed to be. Oh yeah, it's also going to be some sort of record type. But anyway, right, it doesn't really matter. The point is that this signature is the one that's going to be visible to people who call you, and this signature that is the one right on the body, that's the signature that you're going to see in the implementation, right? So you can sort of play with these and, lie a little bit. TypeScript won't let you do quite anything with overload signatures, but it's a lot more relaxed about assignability rules. I'm not saying that this is type safe, by the way. It's not, right? You still need to make sure that you are the one deciding that those assignments are okay and what you're doing in there is okay. But again, don't obsess over this part. Obsess over making sure that people who use this function have a good developer experience. So was that example overly complicated? I don't know. Maybe. Definitely not something a junior programmer would write. Definitely not something a junior programmer will understand from looking at it the first time. But it's something a junior programmer could benefit from, right? You're catching some of their errors and making sure they don't shoot themselves in the foot. That's a worthwhile thing if you're going to write something that is going to be used across your application. Problems usually come when you start layering things on, map types on top of other complex type, conditional types on top of other things. What kinds of problems? Readability and maintainability, they're definitely an issue. Compiler performance, although maybe, like with the TypeScript Go version, maybe that's not going to be so bad, but I'm sure people will find a way to abuse the type system so it will be slow again, now that we're getting 4x performance from conversion to Go. I'm sure people will manage to find a way to take a full advantage of that. Also, when I say readability, I also mean the errors. if you go overboard with the conditional, with the types, the errors are going to be impossible to read, even for you. They're going to be borderline useless. It will be the equivalent of there's an error there. Good luck. And that's not useful, right? Make sure that you actually look at the errors that the compiler will spit out when you're doing something wrong, and make sure that people can actually understand what TypeScript is trying to tell them. Because sometimes you're just going to get a huge pyramid of text that is not actually useful at all. And like I said, you probably shouldn't obsess about the type safety of your generic function implementation. You can write tests for that, right? It's your callers that are probably going to benefit from your complex types, not you. And don't use complex type for single-use code, right? If you're going to have a function that gets invoked twice, it's not worth it. Don't create your own class system in the type system. You can do that. ES already has classes. I'd recommend you use those if you really want classes. We, for example, in Bloomberg do have our own class system written sort of in the type system, but that's because we had a really old class system that existed before JavaScript classes were a thing. So, that was something that we did to help migration and make sure that, at some moment in time, hopefully we can delete that. So it's code that we wrote specifically, so hopefully we can delete it at some moment in time. Don't parse other languages in the type system, right? If you're using a library that's telling you, oh, I'm going to parse the SQL code and I'm going to give you good types for it, it probably can't do it. I've seen SQL parsers written in the type system. Are they any good? I don't know. I've not dared to use them, because the result is definitely that you're going to make your compilation slow, and it'll probably generate hard to read errors, because it's hard to generate custom errors from the compiler. You can do some tricks, but they're still going to be required sort of what to look at. Generally anything that advertises that is taking advantage of the fact that the TypeScript type system is Turing complete, right, and you can do anything in it, that's a red flag that probably that library is going way too far, right? And just there was a recent example of somebody, and they didn't actually do this for any sort of production purposes, but just for fun. They wrote a VM in the type system that could actually interpret enough of the game Doom to actually show a screen in ASCII art as sort of if you hover over the type, you get the first screen of Doom, which is, great effort. It's like wonderful, and but he's not planning to run something in that VM. It was just purely for fun, right? And that's fine. I get it. I like this kind of thing too. It can be interesting, but don't use it in production, right? You should probably get more familiar with some of the more advanced techniques. They can help for sure. You might still benefit from them even if you don't plan to use them, just because you'll understand what other people are doing there. And use these in library code to improve developer experience for your users, and also make sure that you sort of disseminate some of this information so that other people around you can also look at that code and hopefully maintain it in the long term. Thank you very much. I hope this was interesting, and if anybody has any questions, I'm all ears. I was going for applause, but stunned silence is also appropriate.
If there aren't any questions, thank you.
Thank you very much.